Okay, so in today's session, I'm going to share with students 5 strategies. All right, so these are the strategies that we are going to share today. Number 1, repeated identity, equal fractions, external unchanged, total unchanged, and constant difference. Okay, especially for the P6s, some of these questions and some of these strategies are not entirely new to you. You know the name at least, okay, but you must be able to apply to different situation and different difficulty level of the questions. All right. Okay. So students, once we start, I just want you to listen. So please refrain from chatting so that all of us can focus on the strategies. Okay. So I'm going to share with you 5 strategies today. All right. We have other strategies which I'm going to share at another period of time because I want to ensure that the sufficient time is given to cover these 5 strategies thoroughly. Okay. All right. Now, the first strategy is repeated identity. Now, when do we use repeated identity? All right. Now, this concept involves an object or person that is repeated in a question. Okay, from the word itself, repeated identity, this concept, when you see the question, the word problems, it involves object or person which is repeated in the question. Now, this can come in the topic of fractions, ratio, or even percentage. Now, there are 2 methods to solve this. One is the model method, the other one is the unitary method. Now, both methods are okay, right? I'm going to show you both methods. Now, for the P6s, right, if you are solving this for the PSLE, now at times, for model method, it is not practical because it is going to be very troublesome. You're going to cut into many pieces. So that's why I'm going to share with you alternative method to solve this strategy, which is the unitary method. Okay? Now let's take a look. Let's start. I'm going to show you the question so that you can have a better idea. All right? Okay, let's read together the question. Alex had 2/7 as many marbles as Ben and half as many marbles as Charles. If they have a total of 104 marbles altogether, how many marbles did Alex have? Okay, so let's analyze the question. Now here, right, Alex has 2/7 as many marbles as Ben. Okay, so you know that these 2 units, right, these 2 units represent Alex, and this 7 unit is Ben, correct? And you can see from here itself, you can see that Ben has more marbles than Alex, right? Because Alex only have 2 units, but Ben has 7 units. Now, this is the first ratio given to you. Now, in the second ratio, they tell you that Alex also has half as many marbles as Charles. So, Alex here has 1 unit, but Charles has 2 units. Okay? So, you can see there are 2 different ratios, and Alex in this question is repeated. Right? Alex is repeated in this question. Okay, now let's use a model. So we're going to show you step by step, all right, how to solve this question. Number 1, using the model method. Okay, now this question can be quite easy for the P6 students. Okay, but the objective is not for you to eventually get the answer. Okay, so for you to first to see how the strategies that can be used in this particular question. Okay, the model method. And of course, later on, you can see a variation to this question because this is a fraction question. It can come in the form of ratio as well as percentage and different variation. Okay, so I'm going to share with you the most basic part, all right, so that you can apply in other situations. Okay, let's take a look at the model. All right, so method number 1, we're going to use the model method. So they tell you that Alex has 2 units. So 1, 2. So you draw the model. And then Ben has 7 units. 1, 2, 3, 4, 5, 6, 7. Right? So this is the first ratio. Everybody get that, huh? Now, in the second ratio, they tell you that Alex has half as many marbles as Charles. So, half means if Alex has 2 units, we know that Charles will have twice the units, right? We'll have twice. So, how do we draw Charles? So, if Alex has 2, then Charles will have 4. 1, 2, 3, 4. Because they tell you in this ratio that in the second ratio, Alex has 1 unit and Charles has twice as many marbles as Alex. Charles has twice as many as Alex. Okay, so 2 units, 1, 2, 3, 4, 5, 6, 7 units for Ben and 4 units for Charles. And all these, their total number of marbles is 104. Right? So this is another clue that is given to you, which is 104 marbles. So 104 marbles is the total. Right? And which identity is repeated, class? We can see that Alex is repeated. Right? Alex is repeated because in the first ratio, we are comparing Alex and Ben, and then in the second ratio, Alex and Charles. So Alex here is repeated. Okay, so if you were to use the model method, then we count the total number of units. You get 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 unit is 104 marbles. Okay, and then we can find 1 unit. 1 unit will be 104 divided by 13. You get 8. And they ask you, how many marbles did Alex have? So from this model, you can see that Alex has 2 units. 2 units. So 2 units is 8 times 16. So 8 times 2, you get 16. So the answer is 16 marbles. Okay? All right, so this is the model method. Now, next, I'm going to show you the unitary method. Okay, unitary method or the ratio method. Now, let's see how you can represent this question in the form of ratio. Okay, let's take a look now. Okay, Alex has 2/7 as many marbles as Ben. So using the unitary method or the ratio method, Alex is to Ben is 2:7. And Alex is to Charles, the ratio is 1:2. And you can see here, Alex is repeated, right, in these 2 ratio. Right, Alex is repeated. So the way to connect these 2 ratio, the only way is to make Alex the same. Right? So in this first ratio, Alex has 2 units. Right? In the second ratio, Alex only have 1 unit. So for us to compare, you must make sure that Alex is the same, since Alex is repeated, right? Now, how do we compare? How do we compare? By finding the lowest common multiple, called the LCM. Okay, by finding the lowest common multiple. So what's the lowest common multiple for Alex? In the first ratio is 2 units, in the second ratio is 1 unit. So the lowest common multiple is 2, right? So how to make 2? You multiply by 2. In the second ratio, 1 times 2, you get 2. And remember, when you multiply 2 to Alex here, Charles also you must times 2, right? Because these are connected. These ratio are related, or we call them equivalent ratio. Okay, so some students, they forget to multiply 2 to Charles. So when we multiply 2 to Alex, so that this becomes the same, please remember to multiply 2 to Charles also, right? Because all these they are called equivalent ratio. Okay? Okay, so once you get that, you can see very clearly that you can represent the entire ratio together. Alex is to Ben is to Charles. Alex is 2 unit, Ben is 7 unit, and Charles is 4 unit. Okay, so this is the overall ratio after you make Alex the same, right? Because remember, Alex is repeated in this question. Okay, in both ratios. So once you make Alex the same, then you can combine them together. All right, so ratio of Alex to Ben to Charles is 2:7:4. Okay, and next is that we make use of this information given to you. Right, since there are 104 marbles all together, so we add the ratio together, is the same, and you get 13 units, 104. 1 unit, you get 14. Sorry, 1 unit is 8. 1 is 8. There's a mistake here. This should be 8. Okay, 1 unit is 8. Okay, and then you multiply by 2. Why multiply by 2? They ask you how many marbles did Alex have? Alex have 2 marbles, right? So 2 times 8, you get 16 marbles. Okay? All right, Imran got it? All of you got it? Easy peasy? Can, huh? Okay, very good. Tristan, got it? Tasina? Okay, yeah? All right, well done. Okay, so no worries if some of you are stuck, all right, because that's the best part about this online lesson, because I'm recording it and then I'm going to upload onto YouTube and then I'm going to share with your parents. Then any point of time, if you want to revise, you can always review the lesson again and again and again until you are fed up of my face. All right, okay. Now let's take a look at method number 2. Okay, method number 2, strategy 2 is called equal fractions. Now, I'm sure some of you have heard this strategy, right? Okay, Khairi, have you heard of this strategy? Alicia? Good. Who have not heard of this strategy, equal fraction? Who have not heard of this strategy? You forget all the names, huh? Okay, take note, huh? The names are not important, okay? Because this strategy is just names given by book authors or given by educators or teachers to help you remember how to do a certain type of question. Okay, whether you remember or not the name, it doesn't matter as long as you know how to solve the question. Okay, so please don't worry. You say that, ayo, my teacher used another name for it. No problem. Huh? Okay, so because in the PSLE, it's not so straightforward. Huh? There's no such thing as, okay, I remember 50 strategy and I can solve everything. It's not so straightforward. It's not easy. Huh? Okay, you need to be flexible. You need to know as many strategy as possible. And to be able to do that, you need to learn, you need to be exposed to the different strategy, whether model strategy or, this unitary method or ratio method, branching method, all this strategy, you need to know as much as possible so that when you see any type of question, right, you are able to use the strategy from what you have learned and then to solve the question. Okay, the exact name is not a problem. If you don't remember, it's not a problem at all. Okay, so let's take a look at equal fractions. Okay, so when do we use equal fraction? Okay, so here is to compare two fractions that represent equal quantities. Okay, later when I show you the question, then you can understand better. The keyword here, when you see the word equal to, equal number, same as. Now you can use two methods. Number one, model method. Number two, unitary method. I'm going to show you both methods and you are free to choose any of the method, whichever is comfortable to you, right? Because some students, you are familiar with model method. You prefer model method, no problem. Okay, that's very good. Some of you say that, ayo, model method too troublesome for me. I'm not good in drawing. You prefer unitary method, no problem, as long as you get the correct answer. Both are accepted. MOE does not penalize you if you use one method and not the other method, right? As long as your method makes sense and you get the correct answer. Okay? Now let's take a look at the question. Okay, I'll give you 30 seconds to read. All right, in a group of 20 students, half of the number of boys is equal to 3/4 of the number of girls. How many girls are there in the class? Now, in this question, some students, you misinterpret. You think that there are equal number of boys and girls, which is not true, right? They say that half of the boys is equal to 3/4 of the girls. So confirm that the total number of boys and girls cannot be the same. Okay, so I'm going to show you using a model method first. Now, how are you going to show this using model method? Now, let's take a look. Okay, so they tell you that half of the boys, okay, so when you draw half of the boys, right, this is half of the boys, is equals to 3/4 of the girls, right? So half, we draw a bar and cut into two, and this half, right, is equivalent to 3/4 of the girls. So 1, 2, 3, 4, right, is equals to 3/4, right? 3 parts here which are equal. Now the problem here is that you notice that after you cut, right, the units are not equal, right? the size of each unit is not equal. Okay, so you need to do something. You need to cut further such that you have equal parts or equal units, right? Otherwise, you cannot compare. Now let's take a look. So how do you cut, right? So you cut, boys, right? Each part, each unit, each part. So each unit you cut into 3 smaller parts, right? Just now this was 1 and 2, so you cut into 3 smaller parts, and you notice now all the parts are equal size. Okay, so when they are equal size, then we can proceed on to compare. Now we have not made use of this clue here, right? Okay, we have not made use of this clue. There are a group of 20 students. Now how many units is 20? Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so 10 unit is 20. Okay, so total number of students, there are 20. Right, and so 10 unit is 20. 1 unit is 2. How I get 2? 20 divided by 10, you get 2. And then they ask you, how many girls are there in the class? How many girls? Now, this is the total number of girls. Total number of girls represent all this. 1, 2, 3, 4 units. Not only 3, total 4 units. So 4 units is 2 multiplied by 4, you get 8 girls in the class. Okay? Easy, right? Using the model method. Now, however, using the model method have some problems, especially if the numbers are bigger and you have to cut into small pieces. Imagine you have to cut into 65 pieces, for example. So you're going to have problems. So I'm going to show you shortcut, okay, or unitary method. All right, I'm going to show you unitary method so that you can have other options, right, to solve this question faster. Okay, so let's take a look at the alternative methods. Okay, now this method we call units method or the unitary method. Now remember, I'm going to show you side by side, right, the model method and the unitary method, so that you know you can compare the concept that they are exactly the same, right? Because sometimes when your teacher teach you in school or your teachers teach you in school straight away using the unitary method, they tell you, oh, make the numerator the same. Then you just blindly remember to make the numerator the same, but you don't understand why you need to make the numerator the same, right? Okay, because all of you are familiar to make the denominator the same, right? When you study addition or subtraction of fractions. Now, but this is not. This is not about subtraction and addition of fraction. This is to solve equal fraction concept where you need to make the numerator the same. But why? This I'm going to show you. Today you're going to understand why you make the numerator the same. Okay, so I'm going to put both methods side by side, the model method here and the unitary method. Okay, now let's analyze the question again. Half of the boys, you see, I put half of the boys here. Half of the boys is equals to 3/4 of the girls, right? 3/4 of the girls. Now take note. I put boys here and girls here. I cannot put. You cannot put like this. Half equals to 3/4. This is mathematically wrong. If you put in the question in your working half equals to 3/4, straight your teacher will minus marks. Okay, I think at least 1 mark, right? Because half is not equal to 3/4. So how you represent this question in the form of units? You must write boys here, or you can put B, and here you put girls. And instead of putting equal, you put arrow to show that half of the boys represent 3/4 of the girls. Okay, so step number 2 is you make the numerator the same. Now, how to make numerator the same? By finding the lowest common multiple for the numerator. Now, what's the lowest common multiple of the numerator? Since the numerator is 1 and 3, what's the lowest common multiple? Lowest common multiple is 3, right? Now, how to get 3? 1 times 3. Now, remember, when you multiply 3 to the numerator, to the boys here, the denominator also you must times 3. This many students, they forget. When they times 3 here they never times 3. So when you multiply by 3, numerator, you get 3, and denominator, you get 6, right? So then we can compare, right? We can compare this. After the numerator the same, right? So 3/6 boys is equals to 3/4 girls. Now let's take a look at compare with the one in the model. Can you see the similarity? Can you see the similarity between the model method and the units method? What happens when we make the numerator the same? You see, we are essentially making numerator the same. Means we want to make sure the size of each of these parts are equal, right? Because only when the size are equal, then you can compare, right? Now here you cut, remember you cut into 3 parts here. Now likewise here also, from 1 you make into 3, right? And when you cut into 3 parts, here also you make into 3 parts. So you can see there are total of 1, 2, 3, 4, 5, 6, right? There are 6 here, okay? So you can see here. Another thing you must take note of is that these 6 represent the total number of boys, while 4 here represents the total number of girls in terms of unit, not the actual. So 6 units are the total number of total units of boys. For girls, 4 units is the total for girls. Okay, and how many students are there altogether? So you need to add up 6 plus 4. This 10 units, which is you get from 6 adding to 4, right? 6 plus 4, you get 10 unit, and 10 unit is 20. Okay? Understand, Aisha? Okay, so 10 units is 20, 1 unit is 2, and then they ask you how many girls are there? Girls here, this is the total, right? Remember, this is the total, 4 units is 8. Okay, so you get the answer. There are 8 girls in the class. Okay, that's enough. Very good. I'm very happy that you understand now. I know it's not easy for some of you, right? For Dave, I think for you, no problem. But I know some of you are still struggling. Even the P6 student, you don't really understand. Okay, so that's why I have this session to help you further understand, so that when it's uploaded on YouTube, then you can repeat again and again. Okay, so you can see here, and they can ask a different variation to the question. Here they ask you how many girls are there. Then they can also ask you how many boys are there. Boys, 6 units of boys, right? So they can ask you for the total. Total is 6 plus 4, which they tell you this is 20. Okay, so you can see that using unitary method, you don't have to use the model method. So sometimes some questions, it's not possible for you to use the model method because it's too complicated, too complex, right? You're going to have problems, and it's going to take a very, very slow time. Okay, so units method, you need to know, especially those P6 students who are sitting for your PSLE very soon, you need to know this unit method, right? So that it can help you to solve the word problem faster. Okay? All right. Okay, let's move on. Let's move on to the next strategy. Okay, next strategy is called external unchanged. Okay, next strategy is external unchanged. Okay, that's very good. I hope that you can, with this clarification, you can understand better. Okay, external unchanged, all this strategy that I'm sharing with you today, they can be used in the topic of fractions, ratio, as well as percentage. Remember, fraction, ratio, and percentage, they are like brother and sister. Okay, I always tell the students in my class, they are like brother and sister. When they give you in terms of percentage, you can convert to ratio. When they give you ratio, you can convert to percentage. Likewise, also for decimals, you can convert to ratio, percentage, as well as fractions. Right? They are like brothers and sisters. Okay, so these strategies can be applied to the topic of fractions, topic of ratio, percentage, as well as decimals. Okay, now external unchanged, this is not the one which is constant. Okay, I'm going to show you how to use this strategy. Okay, listen carefully. So this concept involves changes that takes place externally. Okay, both model and units method can be used for this concept. Now let's take a look at one example here. Alan and Ben have some marbles in a certain ratio. Ben gives some marbles to Charles. Okay, Charles here is the external party. Remember, you have Alan and you have Ben, and Ben gave some marbles to Charles. And due to this, the ratio of the number of Alan's marble to Ben's marble will change, right? Because Ben has given away some, so the ratio will definitely change. However, you will notice that Alan remained unchanged. Alan is not changed. The one that is changed is only Ben. right? Because Ben gave some marbles to Charles, but Alan did not change, right? So we call this strategy external unchanged, where one of the variables, one of the object or person in the question is unchanged. Okay? Okay, what is the meaning? Externally means you give to somebody outside the ratio. In this instance, you are only comparing Alan and Ben, but Charles is outside the ratio, so Ben gives out. So that means there is a decrease in the number of marbles for Ben. Okay, because we are going to, I'm going to share with you another strategy later on where you give to each other, or what we call internal transfer. So that one totally different strategy. So in this strategy, we call external unchanged because one of the person, one of the unknown, right, one of the object in the question is unchanged, but the other variables is changed. Why? Because they give away or they receive something from an external party. Okay, so don't worry if you don't understand. I'm going to show you an example, then you can understand better. Okay, now let's take a look. First, we are going to use a model method. Okay, we are going to use a model method. Okay, Alex had twice as many stamps as Bernard. Then Alex used some stamps. Because of this, Alex now has 1/3 as many stamps as Bernard. Now, can you tell me who is unchanged here? Who is unchanged? Bernard or Alex? Bernard, correct or not? Because in this question, they say that only Alex used some marbles, not Bernard. Okay, so Alex is the one that is changed, but Bernard is unchanged. Okay, so we are going to draw the before-after model. Now, in the first ratio, you have that Alex has twice as many stamps as Bernard. You can see that Alex twice, double of Bernard. Then Alex used some stamps, and because of this, Alex now only have 1/3 as much as Bernard. Okay, and do you notice that there's no change in Bernard? Since Bernard did not use any stamps, he should have the same number of boxes in the before and after model. So you can see here, Bernard is unchanged, totally unchanged. Initially 3 units, before also 3 units. Who is changed? Only Alex, right? Because only Alex used some stamps, but not Bernard. Okay, class, understand? Okay, very good. Now let's take a look at, let's do another question. Let's do another question. Okay, slightly more challenging. Alex and Bernard has stamps in the ratio of 3:2. Then Alex bought some stamps. Alex now has twice as many stamps as Bernard. Okay, so now who is unchanged now? Who is unchanged? Bernard is unchanged, right? Why? Because only Alex bought, but there's no change to Bernard. Okay, so let's take a look at the model. So Alex at first got 3 times 3 units and Bernard 2 units. Then Alex bought some stamps, and because of that, Alex now has twice as many stamps as Bernard. You notice that Bernard, there's no change. Initially 2 units, in the end also 2 units, but Alex, he bought some stamps. You need to add on to the model for Alex, right? And the ratio now, Alex has twice as many stamps as Bernard. Okay? Easy, right? So since Bernard did not buy any stamps, he should have the same number of boxes in the before and after model. Okay? So here is using the model method. All right? So I'm going to show you next using the units method. How are you going to solve this problem using unit method? So I'm going to give you a slightly more difficult question, okay, involving percentage. Okay? Now, P5 students, have you all learned percentage? My P5 students, any of you have not learned percentage? I know some schools are learning, or some schools are just starting, or you have not learned. Rehan, halfway? Yes, you have learned? Okay, so for the P6 students, no problem. For the P5, okay, I think you need to bear with me, but this is quite an easy percentage. Everybody knows, right? 50% means half. Right? Remember, I told you that percentage and ratio and fraction, they are like brother and sister. Okay, so 50% discount means half price. If you go to a shop, the shop tell you that, oh, today all prices are 50% discount. You know that you can get at half the price. Meaning like last time it's $10, now it's going to cost you only $5. Okay, so I'm going to give you a very simple percentage question and to show you how you can apply this strategy to percentage question. Okay, now let's take a look. Let's read together. In the library, 2/5 of the pupils were boys. After another 8 boys came into the library, the percentage of girls dropped to 50%. How many pupils were there in the library in the end? Let's analyze. Who is changed, who is unchanged? Who is changed, who is unchanged? So we can see that only the boys changes, right? Because more boys came into the library. And what about the girls? The girls is unchanged, right? The number of girls did not change. But the question is, how come the percentage of girls dropped to 50%? Some of you are wondering, teacher, when you say that there's no change in the girls, but how come the percentage of girls dropped to 50%? That's where you need to understand the difference between the actual quantity and the ratio. Ratio and percentage, they are just proportion. They are not actual numbers. Okay, they are just proportion, they are just ratio. For example, if I tell you that, if I go to the shop, I'm going to get 50% discount. Now, does it mean I'm going to purchase it for $50 or $5 or $500? That's different, right? 50% is not the actual price, but 50% is just a proportion. Half is also a proportion, not the actual quantity. Okay? Okay, now let's take a look how to solve this question. Okay, so we know that after 8 boys came into the library, the number of girls remained the same, right? There's no change, right? Because only 8 boys came into the library. Okay, so we are going to write down the ratio. First ratio, right? The ratio is the boys to girls is 2:3. Some of you are wondering, teacher, why 3? Why not 5? You must read the question carefully. The question says that in the library, 2/5 of the pupils were boys. Of the pupils. So these 5 units represent the total number of pupils, including the boys and the girls. If the boys is 2 units, right, the girls must be the balance 3 units. So some students already trapped already. Here they put girls 5 units. Wrong already, okay? So just take note. Okay, what is the second ratio then? In the second ratio, in the after ratio, in the end, they say that the percentage of the girls dropped to 50%. Now take note, they did not say drop by 50%, drop to 50%. And 50%, I'm going to convert it into fraction as well as ratio. Now 50% means what? If the girls 50%, the other 50% must be boys. So the ratio will be 1:1. Or 50% girls and the balance 50% must be the boys, right? Okay, so I simplify, I get 1 unit is to 1 unit. All of you understand this one? Imran, understand this one? Boys 1 unit, girls 1 unit? Yeah, yes, okay, very good. Okay, now, next. What are we going to do now? Alicia, what is the next step? What is the next step? Class, can you type down type in the chat function? What is the next step? What should we do next? Mariam, are you there? Okay. Are you following? Not sure. Okay, the rest of you, those who know, can you type in the chat function? What should you do next? Okay, Farah say make the girls the same. Imran, not sure. Imran, think harder. This is not something very, very strange or very difficult. Hairi, IDK. Remember, this question is about external unchanged, meaning one of the variable is the same and the other variables is unchanged, is changed, right? So who is changed, who is unchanged here? Alicia say make the girls the same, right? Correct, right? Because in this question, 8 boys came to the library, but the number of girls remain the same. So what we do, we need to make the girls the same in both ratio. So we compare here. Now they are not the same, right? The ratio is 3 units and the girls is 1 unit, but we know that there's no change to the number of girls. So what we do, we need to make the ratio of the girls the same. How to make them the same? By finding the lowest common multiple. Okay, what's the lowest common multiple of 1 and 3? What's the lowest common multiple of 1 and 3? 3. Very good, well done. So what we do, we multiply 3 to the girls here. Okay, we multiply 3 to the girls. We get 3 units. And please remember to multiply 3 to the boys also. Why do we need to multiply 3 also? Remember, these are equivalent ratio, right? Don't forget, these ratio are connected. In the end ratio, boys and girls, they are the same. So in the concept of equivalent ratio, when you multiply 3 to girls, here also you must multiply by 3. So you get 3:3. Now then you can compare. You can see girls the same, right? Because there's no change to the number of girls, right? Only boys were added to the library. Only the boys came to the library. The girls did not come. So now then you can compare. You can see here, at first there are 2 units of boys, and then in the end there are 3 units of boys. Why did the units of boys increase? Why? Because 8 boys came to the library. Meaning that 1 unit is equals to 8. Very good, Rehan. Well done. Huh? Okay. So, increased number of boys is 8. And then they ask you, how many pupils are there in the library in the end? How many pupils in the end? So in the end, right, remember, we take a look at this ratio. In the end, 3 units of boys, 3 units of girls, 8 units, 8 times 6, you get 48. 48 pupils in the library in the end. Easy, right? Okay, class, so far so good? Okay, well done. Let's move on to next topic. Huh? Okay, we have 2 more strategy. Okay, 2 more strategy. Actually, I have much more. So today's session, we're going to discuss only 5. Huh? All right, and next few session, we're going to discuss more strategies. All right. Okay, now next strategy, we're going to discuss internal transfer, or what we call total unchanged. Have you heard of this strategy? Total unchanged, I'm sure, right? Some of you have heard of this strategy. Who have never heard of this strategy? Never hear before. Rehan say yes, but you don't know. Okay, no problem. So today I hope that you, you will remember this strategy. You heard of it. It means the total the same. Yes, from the name itself, the total is the same. Huh? So let's take a look. How are we going to apply this strategy? Okay, this strategy, this concept involves changes that takes place internally or changes that involve mutual exchange. For example, Alan and Ben have some marbles in a certain ratio. Then Ben gave some marbles to Alan. Okay, remember, they are together. So both have some marbles. So Ben gave some marbles to Alan. The ratio of the number of marbles Alan and Ben have will change. However, the total number of marbles before and after the transfer will remain the same. It will not change, right? I give you an example, simple example. Let's say Alan has 5 marbles, Ben has 5 marbles. Total, 5 plus 5, they have 10 total. Now, if Ben gave 2 marbles to Alan, Ben has 5, he gives 2 to Alan. So Alan now have 5 plus 2 equals to 7. Ben will have 5 minus 2 equals to 3. Right? So 7 for Alan, 3 for Ben, total is still 10. Right? So how you transfer? As long as you transfer to each other, the total before and after remains the same. Okay? Alright, class? Okay, now in this strategy, you can use 2 methods. You can use model or units method. But units method, model method is a little bit complex, right? Very challenging, very difficult. So you can use a unitary method. I'm going to show you units method, shortcut method. You can do very, very quickly. Okay, let's see how to solve this question. Okay, this is a question on fraction. Tom has half the number of marbles as Ben at first. After Ben gave 12 of his marbles to Tom, Tom had 2/3 the number of marbles Ben had. How many marbles did Tom have at first? Okay, so let's solve this. First, we are going to write down the ratio, the before and after ratio. Okay, so since Tom has half the number of marbles as Ben, okay, so Tom has 1 unit, right? Ben has 2 units. Okay, Tom has 1 unit, Ben has 2 units. In the end, after Ben gave 12 of his marbles to Tom, Tom has 2/3 of number of marbles Ben had. So Tom 2 units, Ben has 3 units. Okay, so this is the easy part. You just list down the ratio as per the question. Then we need to analyze what strategy to use. Now, since we know it's an internal transfer question, meaning that Ben gave to Tom. He did not give to a third party. Like just now in the previous question, in the external unchanged, he gave to a third party, which is outside the ratio. But here they give to each other. When they give to each other, the total number of marbles remains the same. Okay? So what do? We need to find the total ratio before and after. Okay, very simple. How we do that? You just add them up together, right? In the first ratio, Tom 1, Ben 2 units, total, there's 3 units. In the end, Tom 2 units, Ben has 3 units, so total, add up, 2 plus 3 equals to 5. So what we do, since this is 3 units and this is 5 units, we find the lowest common multiple. What's lowest common multiple, class, of 3 and 5 and 3? 15. Very good. 15. Very easy, right? Okay. So how to get 15? In the first ratio, we need to multiply by 5 to get 15. In the second ratio, the total we multiply by 3, we get 15. And remember, when we multiply by 5, don't forget to multiply by 5 to all the related ratio. Here, multiply by 3 to all the related ratio, right? Because these are what we call equivalent ratio. 1:2, and then become 5:10. These are equivalent ratio. Likewise here, 2:3, and then became 6:9. Right? These are all equivalent ratio where they come in pairs. They are connected. Okay? So after this, then we are going to analyze. Right? At first, Tom has 5 units and then became 6 units. Why? Likewise, Ben has 10 units and then dropped to 9 units. Why? Because Ben gave 12 of his marbles to Tom. Right? So Tom received some marbles. So because of that, his units increased from 5 to 6. Likewise for Ben, since Ben gave to Tom, Ben decreases from 10 units. Now it became only 9 units. So you can see how to solve this question, right? So increase in Tom, I repeat, is 1 unit. Decrease in Ben, 1 unit. So 1 unit is 12 marbles. And they ask you, how many marbles did Tom have at first? Tom has at first is 5 units. Remember to use this. Don't use this one. Don't use 1, because we need to use the ratio which the one that after we change. Okay, so since 1 unit is 12 marbles, 5 units for Tom, 5 multiplied by 12, you get 60 marbles. Okay, you get 60 as the answer. All okay, class? Okay, well done. Last strategy for today. We have many strategies. Okay, but in this session, okay, I'm going to share with you the 5th strategy for today, which is constant difference. You heard this one, Yeah, those of you in my class, I think recently we have some questions related to this topic, Tasina, you finally understand. Very good. Finally understand. Okay. IDK, what it means? It means constant difference law. Okay, no problem. Those of you who are not sure, okay, let's see how we apply this strategy. What type of question will require this strategy? And Vandit say age. Yes, very good. Okay, question involving age. But what kind of question involving age? Let's take a look at this, how we can apply this strategy. Okay, so the purpose of constant difference concept, Okay, you can, from the word constant difference means the difference remains the same before and after. The difference remains the same before and after. What is the clue? The clue says both receive an equal amount. Both receive and or give an equal amount. Right? The difference before and after will be the same. Two strategies you can use. Number one, you can use model. Secondly, you can use unitary method. Okay? Now, what type of question involving difference in age? Right? When you see age question, a very high chance that you need to use constant difference strategy. Okay? Or in situation where two individuals receive an equal amount from a third party from outside, receive equal amount, meaning that example, let's say two person receive $5 each, both of them receive $5, or both of them give $5. Okay, so in the end, before and after, the difference will remain the same. Okay, so I'll show you, some of you maybe not very clear, but I'm going to show you an example, then you can understand better. Okay, let's take a look at this question. Okay, when Mrs. Tan is 29 years old, her daughter is 5 years old. In how many years' time will she be 4 times as old as her daughter? Okay, and you know that the difference remains the same, right? Because if the Mrs. Tan is 29, the daughter is 5 years old, the difference is 29 minus 5, you get 24. Right? The difference in their age is 24, and it will always be 24 forever, right? As long as they are living, of course. So that means in 10 years' time, Mrs. Tan will be 39, and the daughter will be 10 plus 5 will be 15. The difference will still be 14, will still be the same. Right? So the difference in the age will always remain the same. Now, the Tasina still use guess and check. Please don't use guess and check. Please do not use guess and check unless it's the last resort. You got no clue, then you use guess and check. Why cannot use guess and check? Number one, guess and check is basically just like guessing. You don't know how to solve, you just guess. That's why we teach you different strategies so that you can use the appropriate strategy, the shortcut strategy, you can solve very, very quickly. Okay? So in this particular question, we are going to use constant difference. All right? Now, let's take a look. Okay, so Mrs. Tan is 29 minus 5, which is 25 years older than her daughter. For every 1 year that Mrs. Tan lives, her daughter will also live 1 year as well. So it follows that for every 5 years that Mrs. Tan lives, her daughter will also live 5 years as well. So note that the difference in the age will always be the same. That's why we use constant difference strategy. Okay? Let's take a look at other situation. Another situation, when both receive an equal amount from a third party. Okay, and Ali has twice as many marbles as Benny at first. Then each of them bought an equal number of marbles. In the end, Benny had 39 marbles and Ali had twice as many marbles as Benny. Find the number of marbles Ali had at first. Okay, so let's analyze this question. Right? Each of them bought an equal number of marbles. Okay. Now, since Ali has more marbles than Benny at first, each of them bought an equal amount. It means that if Ali buy 1 marble, Benny also buy 1 marble, and so on. If Ali buy 2, Benny also buy 2. Okay? So, the increase, the same amount of increase for each individual. Right? So, the constant remains the same. Right? Sorry, the difference remains the same or remains constant. Okay? So, by logical thinking, the difference will always be the same. That's why we use the constant difference strategy. Okay, let's try. Let's take a look at this question. Model method. Okay, back to the question on Mrs. Tan and her daughter. Okay, so we know that the difference in the age is 24. 29 minus 5, you get 24. In how many years' time will be she 4 times as old as her daughter? So if you draw a model, 4 times, 1, 2, 3, 4, daughter 1 unit. And since we know the difference will always be the same, and we can see the difference is 3 units, right? So meaning that 3 units is 24. Very good. 3 units is 24 years old. Then we find 1 unit. 24 divided by 3, you get 8. And then 4 units, you get 32. So that means here, Mrs. Tan is 32 years old. Right? So when Mrs. Tan was 32 years old, she will be 4 times as old as her daughter. And how many years time will that be? Remember at first, Mrs. Tan is 29 years old, right? So 29 to 32, the difference is 3 years, 3 years old. Okay, in 3 years time, in 3 years time. 32 minus 29 in 3 years time. You understand? All of you understand? Tasina? Imran? Farah? All okay? Yes? Very good. Okay, what about Eunice method? Now, how do we use Eunice method in this question? Okay, so Mrs. Tan is 29 units, daughter is 5 units, the difference is 24 units. In the end, Mrs. Tan 4 units, daughter 1 unit. So you can see the difference, right? The difference is 24 in the beginning. In the end, the difference is 3. Remember, the strategy constant difference, we need to make the difference the same by finding the lowest common multiple of the difference. Okay, so how? Times 8, right? Because why? 3 times 8, you get 24. Right? So why? Because we are making the difference the same. When you times 8, everything also you must times 8. That's why you get 32. 4 times 8, you get 32. 1 times 8, you get 8 units. Okay, so that's why using the constant difference strategy by making the difference the same. Right? In this particular instance, the difference is 24. The lowest common multiple is 24. Then from here, then we can compare. Right? Okay. So here 24. Alright. And then Mrs. Tan 29. And in the end, Mrs. Tan 32. So 32 minus 29, you get in 3 years' time. Okay? In 3 years' time. Alright, class? Understand? Okay, very good. Now, any question?